Okay, so for this circuit, we have to find the resistor load that will draw the maximum power from the rest of the circuit, and then find the maximum power. So to find maximum power, it's equal to VTH all over RTH plus RL squared times RL, and RL is equal to RTH. Okay, so that this by itself means that when the resistor load is equal to the Thevenin resistance, that's when you get your maximum power. So this formula, replacing RL with RTH, we get the following. Okay, so we already know what RL has to be. RL has to be RTH. So let's start by trying to find that. So let's start by getting rid of this section of the wire for now, and looking for RTH. So we turn off all independent sources, so we can put a short circuit here. But obviously we can't do that here because this is a dependent source. So we'll redraw the circuit like this. And then for this region, we'll put a test charge. Let's call it 1 volt. That means RTH will be 1 over the current passing through it. So I here. Okay? This is 4 ohms here, this is 1 ohm here, this is 3 Vx, and this is 2 ohms here. And then plus at the bottom Vx, and then minus on the top. Okay, I just pretty much moved this over here. You can do that. Alright, let's see what we can do now. Let's do a nodal analysis. So let's call this node VA. Let's have a current passing through here. Let's call this I1. Current passing through here. Let's call this I2. Okay, and this is the ground node, 0 volts. So for node VA, it's I1 plus I2, they're both leaving, and this is equal to I, which is entering. So I1 is VA minus 0 all over 2, plus I2, it's VA minus 3Vx all over 1 equals I, which will be 1 minus VA all over 4. Okay, so 1 minus VA all over 4. Now we have to find a way to get rid of this Vx. We see Vx will be equal to 2 times the current passing through it, and we see the current passing through it is I1, but it enters the negative terminal first. So it'll be minus I1, so Vx will be minus 2I1 here. So this one will be that. Okay, so let's continue. So minus 3 times minus 2I1, that'll be plus 6I1 all over 1 equals 1 minus VA over 4. And I1 was equal to VA over 2. So we can replace that with VA over 2. 6 over 2, that's 3. So 3 VA. Alright, so 3 VA plus 1 VA, that's 4 VA. Alright, so 4 VA plus 1 over 2 VA, that's 4.5 VA equals 1 over 4 minus VA over 4. Bring this to the other side. So 4.5 plus 1 over 4, that's 4.75. VA equals 1 over 4. So VA will be equal to 1 over 4 divided by 4.75. That's 0.05263 volts. Okay, now we know this 1 minus VA over 4, that gives you I. Okay, so 1 minus 0.05263 all over 4. That gives me 0.2368. That's my I value. So RTH will be 1 over 0.2368. So that's 4.222. So this is what RL has to be to draw the maximum power. RL will have to be 4.222 ohms. Alright, so now let me erase all of this. Now we have to find VTH to solve for the maximum power. So what we'll do is we're gonna ignore this part of this circuit, okay? And so we'll replace it with an open wire. And since this section is an open wire, the current passing through here is 0. So that means we can ignore this. So we have to find VTH, which will be the current here. So we're going to ignore all of this. We're going to draw a direction of current here. Let's call this I1. And let's get a direction of current here. I'll call it I2. So node VTH, it's I1 plus I2 equals 0. I1, it's VTH minus 9 all over 2 plus VTH minus 3Vx all over 1. Now, Vx is equal to 2 ohms times the current passing through it, which is I1, but since it's entering the negative terminal first, it's minus I1. So it'll be Vx equals minus 2 I1. And I1 is equal to this thing. So it'll be VTH minus 2 and all of that. This and this cancels out. And then the minus 1 we distribute it inside. So it'll be 9 minus VTH. So we have VTH minus 9 over 2 plus VTH minus 3, 9 minus VTH. Okay? Now we have VTH minus 9 over 2 plus VTH minus 27 plus 3 VTH. Let's combine like terms. So we have all of these. So 1 over 2 plus 1 plus 3, that's 4.5 VTH. And then the second group of like terms, it's this and this. So minus 9 over 2 minus 27, that's minus 31.5 equals 0. Bring it to the other side, so it'll be equal to 31.5. So VTH will be 7. Okay? Now we can solve for the maximum power. It'll be 7 squared all over 4 times 4.222. And let me see what this gives me. It gives me 2.901 watts. And that's your final answer. That's the power max.